The origin of construction can be traced to man's impulse to create shelter. Protection from the elements such as heat, snow, wind, and rain is essential to man's basic survival. To compensate for climatically uncomfortable indoor environments, we began to incorporate cumbersome physical and mechanical systems in the late 19th century. Ventilation, air conditioning, heating, vapor barriers, and artificial lighting, costly and high-maintenance systems, became the status quo in housing construction. But today, as natural resources become ever more scarce, the need for sustainable building systems is greater than ever. In developing nations, most highly concentrated in the tropics, energy use accrues to twice as much as in developed nations due to population size. By 2050, developing nations will use 5 times as much energy as developed nations. To this end, the development of high-tech solutions for low-cost applications is critical. So what if we could do away with all those energy-guzzling mechanical systems and their laborious, costly maintenance? What if a single-layer wall system could mitigate multiple climatic conditions with zero energy input and zero mechanical systems? Meet SABERs, an innovative net-zero energy building enclosure system that can optimize water, heat, and light transmission with no mechanical input and an extraordinarily thin profile. SABERs consists of a pore that opens with increasing temperature and dehumidifies to regulate interior climates. Light transmission through a lens increases as light intensity decreases. Net zero multifunctionality is achieved, as in nature, by having the material be the system. Due to its small size and modularity, SABERs can be applied at a variety of scales, from rapidly deployable emergency housing units to large stadiums and arenas, and from the housing scale to the buildings and urban scale. In current lab experiments, we've developed elastomeric cells that swell as temperature decreases, insulating interior environments from heat loss. As temperatures increase, the cells contract, allowing fresh air to flow through. Through a custom-developed 3D printer, a construction-grade flexible substrate is fabricated, allowing for complex geometry to be cheaply made and optimized for its task. From the lab to the building, inert matter becomes alive and revolutionizes how buildings relate to the environment. Active matter is the new passive architecture.